Let X be the set containing 1, 2, 3, Y is the set containing 1, 2, 3, 4, and Z is the set containing 1, 2. Part A, define a function f from X to Y that is 1 to 1 but not onto. Now 1 to 1 means that every output of the function is unique, meaning that you can't get the same output with two different inputs. Not onto means that not every element in the codomain is an element in the range of the function. Now, I'm going to do each of these parts in a different way to illustrate the many different ways you can answer this question. There are lots of different functions that we can define that are 1 to 1 but not onto. Let's go through an example. Now, since it's 1 to 1, that means that if I draw an arrow in this arrow diagram, then we need to make sure that every output, then we need to make sure that there are no outputs that have multiple arrows pointing to that element. So that means 2 has to be pointing to a different element than 1, and 3 has to be pointing to a different element than 1 and 2. So it's 1 to 1 because each output here is unique, but it's not onto because there are elements in the codomain here that are not in the range of the function. They're not actually outputs of the function. Let's try part B. Define a function g from x to z that is onto but not 1 to 1. This time, we're going to define the function using a table. To do this, we have to be a little bit more careful, though. And by that, I mean we need to make sure that we write down every element in x in our domain here. So x contains the elements 1, 2, and 3. These have to be inputs into the function. And so we need to figure out what the outputs are. Now, the outputs can be either 1 and 2, but we need the function to be onto and not 1 to 1. Onto means that every element in Z is an output. So to ensure that 1 and 2 are outputs, we can just add them to our set of outputs here. Wherever we want, we can put the 1 here and the 2 here. But it can't be 1 to 1, which means that these outputs can't be unique. That means there needs to be 2 outputs that are the same but correspond to 2 different inputs. Now, so far, all of our outputs are unique. So let's add another output here that's a repeated output. So now in this case, there's an output that is repeated, which means it's not 1 to 1, but every element in Z is an output. 1 is an output and 2 is an output, so it is onto. Part C says, define a function h from x to x that is neither 1 to 1 nor onto. So that means that we have to have repeated outputs, and we need to make sure that not all of the elements in the codomain are outputs. So x is 1, 2, 3, so this is from x to x. This time we're going to use function notation. So here we have all of our elements that are inputs, and we need to choose the outputs from the codomain 1, 2, 3, so that the function is neither 1 to 1 nor onto. Now the best way of doing this, I think, is to set all the outputs to be the same. This function's definitely not 1 to 1 because there are repeated outputs. It's also not onto because not all of the elements in the codomain, which is the set x, are outputs here. We're missing the output 2 and we're missing the output 3. And lastly, for part D, define a function k from x to x that is 1 to 1 and onto, but is not the identity function. I'll put D off to the side over here. Once again, we'll use function notation this time, but we need to make sure that we don't use the identity function. The identity function is specifically the function that maps each element to itself. So we're not allowed to use this function, even though it is 1 to 1 and it is onto, since every output is unique and since every element in the codomain is an output of this function. So we're not allowed to do this, but we still have to maintain that this function is 1 to 1 and onto, which is going to be pretty restricting here. We still need the outputs 1, 2, 3, and there are only 3 inputs to map to those 3 outputs. We just need to make sure that it's not the identity function, so we can do something like 3, 2, 1. In this case, all of the outputs are unique, they're all different, and every element in the codomain is an output of this function. Also, it's not the identity function since these elements are not all being mapped to themselves. Yes, 2 is being mapped to itself, but that's perfectly fine because the identity function maps every element to itself, and this is not doing that. So this function is not the identity function. Thanks, everyone, and I'll see you in the next video.